Hi there, my name is Georgia, and I'm going to show you today how to use the LandWISE Nitrogen Budget template. This template was designed to support growers to document their use of nutrients, including using good management practices supported by recognised guidelines. The template also helps growers to document their fertiliser plans on a crop-by-crop basis. There are two templates, one for nitrogen and one for phosphorus, as the management and soil testing policies you apply to these nutrients are slightly different. They're available from the LandWISE website and can be downloaded and printed on A4. The templates are designed to integrate recommendations from the book Nutrient Management for Vegetable Crops in New Zealand, written by Jeff Reed and Jeff Morton, and published by Horticulture New Zealand and the Fertiliser Association. This book can be downloaded from the Fertiliser Association website, and hard copies are available to growers from Horticulture New Zealand. Using the example of a broccoli crop we grew here at the microfarm in Hawke's Bay, I'm going to go step by step on what resources you need to refer to and how the calculations work. So let's get into it. Starting with the first section, I'm adding my name, paddock details, and crop information. Moving on to section 2, the fertiliser plan. Here is where I'm going to use the Nutrient Management for Vegetable Crops book by Jeff Reed and Jeff Morton. The book is a set of recognised guidelines that use expected crop yield and soil fertility levels to recommend fertiliser inputs. If we go to chapter 5 of this book, there is recommendations for cabbage, broccoli and cauliflower crops. For a winter planted broccoli crop, the book suggests a yield of 16 tonnes per hectare of harvested heads, so we'll go with this number for now. This yellow box is where I enter the expected yield for the crop. In our example, we're going with the book suggestion of 16 tonnes per hectare. In this green box is where we enter the soil nitrogen levels for the paddock. We had a lab test done before planting, and the nitrogen levels were found to be 90 kilograms per hectare using the AMN test. So I enter that in this box and tick the soil test that we used. In our example, it was also sampled to 15 centimetres. In table 5.1, the book recommends total nitrogen fertiliser rates per hectare for the cabbage, broccoli and cauliflower crops planted in winter or summer. Going with the book's suggestion of 16 tonnes per hectare of marketable heads and our soil test, which gave us 90 kilograms of nitrogen per hectare, the book suggests we should apply 85 kilograms of nitrogen per hectare total. This box here is where we enter the nitrogen required that the book has recommended based on our soil information and our expected yield. So I'm going to enter 85 into this box. Next we minus the residue supply. This is the amount of nitrogen that is becoming available as crop residues from the previous crop break down. In our case, the paddock had just come out of sweet corn, which has a carbon to nitrogen ratio of about 30, so we don't expect very much free nitrate to become available for our broccoli crop. If you have residues from a recent crop, you can weigh them from a known area, say 4 to 6 samples of 1 metre long beds, and multiply that number by the crop's nitrate concentration. You can get the nitrate concentration from a lab tissue test or from standard values. Now, based on our calculated nitrogen needs and other nutrient requirements, I'm going to plan out what fertiliser we should apply to the crop. Generally, a base fertiliser isn't needed with a broccoli crop, as we can apply late in the season with banding placement machines, so I'm not going to add one at planting. About 4 weeks after planting the broccoli, we're going to apply the first side dressing of Yaramilla 12-10-10, which is 12% nitrogen. If we apply 325 kilograms per hectare of this product, that will total 39 kilograms per hectare of nitrogen. Splitting up the fertiliser applications will reduce the risk of a heavy rain event causing leaching and the need to apply more fertiliser. To make up the final 46 kilograms of nitrogen required, I'm going to add a second side dressing of N-rich urea at a rate of 100 kilograms per hectare. This brings the total N applied to 85 kilograms per hectare. Moving on to step 3. Here the planned surplus or deficit is calculated. This is a straightforward process where the nitrogen required is subtracted from the nitrogen applied. If the number is positive, there is a surplus of nitrogen. If there is a negative, it is a deficit. So bringing these numbers down, the nitrogen applied equals 85 kilograms per hectare. The nitrogen required equals the 85 kilograms per hectare the book recommended, minus any nitrogen that is going to be supplied from previous crop residues, which in this example is 0. So, the result is 0 and the budget is balanced. We think we've got just the right amount of N planned to go onto this crop. Things may change as the season progresses, and in the next section we're going to record what we actually did. The final step is to do a post-harvest assessment. This is when we check fertiliser was applied according to plan, or if in-season factors caused us to make adjustments. If what we did was different to what we planned, the justification for these changes can be explained in the justifications box. In this example, we had a heavy rain event on the 5th of July. A couple of days later, we tested the soil nitrate levels using the nitrate quick test and found the soil N to be low, so extra nitrogen was required to achieve our crop yield. A urea side dressing was applied at a rate of 50 kilograms per hectare, which increased our total nitrogen applied to this crop from 85 kilograms to 108 kilograms per hectare. Therefore, our actual fertiliser applied to this crop was 108 kilograms of nitrogen per hectare, including the third side dressing that we did. As we mentioned before, measuring the actual yield by going out and weighing samples from a known area will give you a better idea of how much nitrogen you're removing from your paddock. If we assume that the actual yield was the same as the expected of 16 tonnes, we can calculate the crop nitrogen removal from using the Nutrient Management for Vegetable Crops book. Table 5.2 shows us the concentrations of different nutrients for different parts of the plant. For broccoli heads, the part we are harvesting, there is 4.1 kilograms of nitrogen per tonne of yield. So we should times 4.1 by the number of tonnes per hectare of yield that we have. Subtracting the crop nitrogen removal from the actual nitrogen fertiliser applied gives us the final nitrogen surplus or deficit number. In our case, 108 minus 66 gives us 42 kilos of nitrogen per hectare. The number is positive, so we have a surplus. A post-harvest soil test can help verify the nutrient budget by measuring how much nitrate remains. Using the quick nitrate test, you can assess how effective your fertiliser plan was. High nitrate levels post-harvest would indicate too much nitrogen has been applied, or that the crop has underperformed, whilst very low nitrate levels could suggest the crop did not have enough nitrate towards the end of its growth. Our nitrate quick test came back with a result of 20 kilograms of nitrogen per hectare, which is pretty reasonable. We tested to 60 centimetres to take account for the full rooting depth of the crop. However, it's important to note that the next crop will start with shallower roots, so might not be able to access all of this nitrogen. The crop residue remaining is the amount of nitrogen that will become available as the crop residues that are left behind begin to break down. Ideally, you should weigh a sampled area of the residue in the paddock left after harvest and send it to a lab for tissue testing. However, it is possible to estimate this figure using the Nutrient Management book. Assuming the same yield scenario, the book tells us that a 16 tonne per hectare broccoli crop will grow a total biomass of 90 tonnes per hectare. Therefore, 74 tonnes per hectare, which is over 3/4 of the plant, is left behind as crop residue. Returning to table 5.2, if we multiply the nitrogen percentage in the broccoli leaves and stems, which is 2.8%, by 74 tonnes of the crop residue remaining, this gives us 207 kilos of nitrogen per hectare that is remaining in the crop residue. When you complete the next crop's nitrogen budget, carry this number forward into the first section in the residue supply box. But use this number with caution, as the C to N ratios, soil temperature and environmental factors will affect how much nitrogen is actually available for the crop. So that's a quick run through of how to use the LandWISE Nitrogen Budget template. As always, feel free to get in touch with any questions. Thanks for watching, and thank you also to our sponsors. This video was proudly supported by our future-proofing vegetable production sponsors. They are MPI's Sustainable Farming Fund, Balance Agri-Nutrients, Potatoes New Zealand, Horizons Regional Council and Gisborne District Council.